At this time, we're very excited to welcome Ms. Anabella Maria D. Galang, the founder of STEMinus movement. She is a senior at the Community School of Naples and has some wonderful things to share with all of us. Anabella?
This is charades. Rotate. Which is on top. Good morning. Hello?
Doesn't have a light. But it's working. Oh, that's great.
Good morning, everybody.
Good morning.
So, any chance I could have some slides, please? Awesome, thank you. All right, so it is a bright and early 8:47 in the morning, and I'm looking out on some pretty sleepy faces. So I'm gonna ask that everybody out there in the audience, I know you just settled in, can you please stand up? We're gonna do some really fun exercises really quick. Go ahead and put some stuff down because you're gonna be using your arms. Are you ready? I know, I'm like your gym teacher, I'm so sorry. All right, so are all of you ready? So first, I want you to stretch up, up. Now out, as far out as you can. I want you to feel the tug in your arms. Now back up, and out. Now, you're gonna be crossing that middle axis of your body. Take your right arm, your elbow, touch your left knee. You're gonna cross. Other one, cross. We're gonna do one more time, cross. Other time, cross. Alrighty, thank you all. Sit down. Thank you. Alrighty, so once you're all settled, alright, great. So my name is Anabella Maria Galang. I'm 17 years old and I'm a senior in high school. What does that mean? Well, that means that I'm in 12th grade. Most of you are in 5th grade. So by my calculations, that means that I am about 7 years older than you. That sounds like a really long time. It's actually not. In fact, oh, I need this clicker. Okay. So, in fact, if I think back to my 5th grade years, I can remember a couple things about what I was interested in. And I'll be honest, my main thing was ballet. I loved ballet. I would go to the studio all the time. Can I see a show of hands? How many of you have done some sort of dance ever in your life? Yeah? Woo, that's a lot of hands. Great. So ballet was a really big interest for me at that time. In addition, I had some really weird interests in different cultures. Now, when it comes to ancient Egypt, there are a couple really interesting things about ancient Egypt. Does anyone know anything about Egypt? Yeah, go ahead, shout it out.
So a lot of people die building pyramids there.
Well, yeah, that's true, definitely. And those pyramids are actually world wonders of the ancient world. Yes, you in the floral top.
They worship Michelle. I need help.
Yes, that is totally true. They had a completely different culture. All right, and then another one of my interests was the Chinese language. So I studied Chinese. And that was really interesting because that really forces you to delve into a different avenue of study and to explore a new world. Some other interests were math, quiz bowl, and debate. And I loved public speaking, and I loved talking to a lot of people and sharing my ideas. Lastly, were just a couple fun things. I love singing and baking. But without further ado, now that you know a little bit about me, let's talk about STEAM. So, When I first heard the acronym STEAM, it's a fairly new one, so I didn't really know what they were referring to. Can anyone give me a refresher? What does STEAM stand for? You're wearing like a white long sleeve top. You're right there. Yes, ma'am. Ah, yes. Thank you so much. I needed that. Alrighty. So STEAM stands for all these different avenues of study. It's basically STEM plus art. But something that's super cool about science is that science is all around us, especially because we're here in Florida. The Everglades is literally about a 1 to 2 hour drive away, and it is a magnificent national park. It's home to over 360 different types of birds, and it's one of the few places in the world where alligators and crocodiles can live in harmony. So, science is particularly interesting because it's the study of literally everything that goes on in your life. There's biology, which has to do with the smallest unit of life, known as cells. And there's also chemistry, which go even smaller to something called an atom. And then there's physics that describes the way that everything moves and the way that everything interacts with each other. And it puts numbers to that. Also, there's studies about the world itself, and that's geography. And that talks about the different layers of the earth and then the way that the earth just interacts with itself. It's absolutely fascinating. The next part is technology and engineering. And I've been studying the gender gap in STEM for a very long time. And technology and engineering is the part of STEM where girls are the least there. It's where the gap is most prevalent. And so you have to ask yourself, why is this the case? Well, what researchers have found is that girls aren't really sure what technology and engineering entails. Because the way that the media portrays it, it's just a lot of guys sitting in a room on computers, just not talking to each other, you know? So, one thing that I found really interesting about technology and engineering has to do with computers and computer science. How many of you have a phone? Yeah? All right, keep that hand up if you've used a computer in the past month. Yeah? Okay, awesome. Go ahead and put your hands down. Yeah, I like keeping you guys moving. So technology is extremely prevalent in our lives. It's everywhere, especially nowadays. We're really lucky because we get to live in a period of intense growth. My older brother, who's only 22, he can remember a time without internet. It's crazy. Sorry. So when it comes to technology and engineering, that's bridging the gap between the hard science. So when you sit in your science classroom and you memorize terms and you learn these different concepts, technology and engineering bridges the gap between what you're learning in that classroom and the real world. And that's extremely important because everything you study has a legitimate purpose in the real world. So some examples of engineering, you may have used this morning if you brushed your teeth. So one example would be the cover of a toothpaste cap. So if you have one of those tubes of toothpaste that has a cap on it, you'll notice that you can unscrew it and there are these ridges. And those ridges were placed there by an engineer to make it easier to open. And so because they went through that thought process, they applied engineering. So the next thing I'm going to talk about is art. Now, let me see a show of hands. How many plays a musical instrument here? Anybody? Voice counts. Voice counts. All right, pink jacket right here. What instrument do you play? Ukulele. Ukulele is really cool, really popular. Awesome. So the way a ukulele works is you pluck the strings and it allows the instrument itself to vibrate. And then it emits different frequencies of sound, and those are those different notes that you hear. So even in art, there are all these different aspects of STEM, science and technology. There's engineering that goes into the body of the ukulele because it kind of looks like a gourd, you know? It's like boom, boom, yeah? So the last thing I'm going to talk about is math. And I'm going to have you do a little bit of math later today. But when it comes to math, math is just a way of thinking. And numbers are literally everywhere. Numbers go into absolutely everything you do. And yet, a lot of people think math is kind of scary, but it's really not, because you've been thinking in terms of numbers your whole life, and you just haven't quite realized it yet. So now that we've gone over all the different aspects of STEAM, we're going to go into combining them and seeing what we get. So this is combining science and then technology and engineering. So this is a picture of a guy who's trying to pick up a block, and it looks like that block is extremely heavy. But with the use of technology and engineering, he's using that little wheel at the top called a pulley in order to make his life a lot easier. So just by using simple machines, he's able to make his life a lot easier and solve problems. So next, this is actually a picture of yours truly. Hello. I'm also a ballerina, and so this is a pose called first arabesque that I'm not going to try in these heels. And as you can see, I've turned it into a sort of force diagram, so you can see all the different forces I've enacted in order to make this position possible. So, this demonstrates the integration between science and art, two very different things that you wouldn't think go together. But actually, they're very similar in that in order to reach a desired goal, you have to think about every single one of those different aspects in order to reach said goal. So, if you look over here, you'll see that all those different forces are acting in order to make this rather beautiful, if I do say, pose. So this is just an example of how science and art can integrate to make something beautiful. So this is the integration between technology and engineering and mathematics. Who's ever heard of the term programming before? Or keep your hand up if you've coded yourself before. That is a massive amount of people. When I was your age, I did not know how to code. I did not know how to code until I was 12 years old. And this showing in the background is actually a type of coding. But when I was your age and I didn't really understand what coding was, someone explained it to me in a really simple way that I'll explain to you now. And that is going to be, coding is essentially telling the computer what to do. So I'm going to ask that you repeat after me. Coding is telling a computer what to do. Coding is telling a computer what to do. Wonderful. So, when you're telling a computer what to do, it can make your life a lot easier, and it can help with a lot of different problems. So, there's this big issue going on right now called big data, because a lot of us are using phones now. You guys know what I'm talking about, right? Yeah? So, as we have more and more data in our lives, we need to find ways to organize it. So this is something called an algorithm. Can you guys say that, algorithm? So whenever you write a code that completes a goal, that's just called an algorithm. It's a big, scary word that just means code that completes a goal for you. So the name of this algorithm is bubble sort. So what it does is it goes through a list of however many terms you feed it, and it orders them in order to least to greatest, as you can definitely see. This is just a visualization of what a bubble sort is. So next, I told you I was going to make you do math. So we're going to talk about something called the Fibonacci sequence. Now, the way that this sequence works is you add the two former terms. It starts with 1-1, as it's shown here, and then the third term, that first blank, is the sum of the last two terms. Hands, who knows what that third term is going to be? Blue headband, right there. 2, yes, perfect. All right, next blank. Let's just keep those hands up, actually. White bow, right there. Yes, awesome. All right, does someone else want to fill in one? Right here, yeah. Yes, awesome. Oh, and then 8, sorry, someone fill in the last one for me. Purple long sleeve. 13, yes. See, so this is the Fibonacci sequence, and let me tell you, it goes on for infinity. It goes on forever and ever and ever. But why are we talking about the Fibonacci sequence in the first place, right? Like, why does this matter? This is addition. Well, while you keep adding these numbers forever and ever, you start approaching a really, really specific fraction when you take the last digit and you divide it by the one former. So this is just a lot further. I did a lot of addition. So you can see here, 377 and 233. So if I took 233 and divided by 377, it would give us a very special number that occurs in nature as well as in a lot of human products. That's called the golden ratio. And that golden ratio is present in a lot of art, and this shows how art and math are actually very intimately related. So, as you can see here, this is a very famous Japanese painting. It's called The Great Wave. And the Fibonacci sequence is present here because that spiral follows that pattern with a radius of 1, 1, and then 2, and then 3, and then 5, and then you guys did the math already, I won't bore you. So you can see how math has been integrated with this painting in order to bring us a very aesthetically pleasing painting. This is also present in nature because when you look at a pine cone, you can see, if you count all the different seeds that are coming out of it, it's usually a Fibonacci number. So it's prevalent in nature, and it's also prevalent in art. But this just goes to show how math is beautiful. I know, it's really interesting. So now I'm going to jump the topic a little bit. I'm going to talk about why I love STEAM. So one of the things that drives my interest in STEAM is that, well, when I was younger, my parents would always push me to read a lot of different science magazines, and they would bring me to a lot of different science museums, and they really encouraged me to ask questions about the world around me. So if we were in a car and we were driving along, I would always ask myself, well, what could be done to make this car, drive better? Or if you read an article about someone getting sick from a very rare disease, what kind of different treatments could I create in order to help that person get better and better? One of the main points of STEAM that has really driven my career, I suppose, as a scientist, I'm only 17, that's why I said I suppose. One of the things that has driven me was this interest in a very deadly disease called cancer. Now, how many of you know someone or is someone whose life has been somehow affected by cancer? First of all, I'm very sorry that you had to do that, had to go through that. And second of all, I had that same realization when I was about 13 years old. Because I realized that cancer is a very large and dominating problem in today's society. And so I wanted to understand why we haven't figured it out yet. Scientists are extraordinarily intelligent, and they work really hard to achieve their goals. And yet, for some reason, people were still dying of cancer, even though there are literally thousands of people across the world working on it. So that's why I started looking into biology. And I started reading about cells and the way that cells work and interact. And that's something that was very near and dear to me, and that's something I continue to work on. In regards to art, I found that art does a really good job of describing life. So that's actually an overarching topic that goes across all these different fields. So when I heard the acronym STEM for the very first time, I'm so sorry, I'm thinking way back when. When I heard the acronym STEAM for the first time, I actually thought that that was really interesting because all these different fields have something in common. They are all different ways that people are trying to understand life. So when it comes to science, they want to get down to the nitty-gritty of why and just asking a lot of questions and understanding the way things work. When it comes to technology and engineering, it's using that to make people's lives better. When it comes to art, people often write books, or paint a painting, or play ukulele, or dance. And they do that so that they can describe the movement or the emotions that come with life. And then lastly, math. Well, math is an excellent way to numerically describe life. So you can use it to describe motions and also just different amounts of things. Numbers are everywhere. And so STEAM has very deeply impacted my life. So here's why you should also love STEAM. Well, like I said earlier, we're living in a very quickly developing world. And all of you are here because you applied to be here. And in fact, can you guys tell me any of the reasons why you applied to be here in the first place? Just out of curiosity. Yes, so you are wearing a pink headband with pink stripes on your shoulders. You've got reddish hair. I'm looking right at you. Yes, you. Hand on your head.
So I can get a good job.
A little bit louder, please.
So I can get a good job.
Yeah, so you can get a good job. You are thinking really far into the future. And that is wonderful. Thank you so much for that. Anybody else? Yes, right here. And why do you like it? That is awesome. You're interested in things and how they work. That is great. That's exactly what this stuff is. Yes, right back there. Yes, nice and loud for me, please. You want to learn something new. That is absolutely amazing. I'm astounded that everyone here is so eager to learn something new. So, it looks like I don't really need this slide because you're all here and you all love STEAM. So that's wonderful. But one thing that's really interesting and that I've discovered in this journey of science, technology, engineering, and mathematics, and art, I always forget, I apologize, is that there are going to be some times where not everything's going to go the right way, and studies are going to get hard. You're in 5th grade right now, you're going to go to middle school next year, and then you're going to go to high school after. And if you try really hard, then you're also going to go to college after that and continue studying. You've got a great wide world, and you are the next generation that's really going to help and get us out of a lot of the pickles that we are in right now. So, if there's one thing that the world has no shortage of, it's problems. And I am absolutely thrilled that everybody here is excited to combat those problems using all these different aspects of study. So, at this point in time, I would like to open up the floor to anyone who might have any questions for me or for this presentation. Does Does anybody have any questions?
Tell us about the fact that you just you're going to the state level with your science project about
Thank you.
cancer and cells. That's very interesting.
Thank you so much. Yes. So I thank you. I found out last weekend that I won grand champion of the Collier Regional Science and Engineering Fair. Thank you. In a couple of years, I want to see someone here do that too. Just saying. So I'll give you a little look into what my project was. So we all know what cells are, right? Yes? I'm seeing nodding heads. Wonderful. So inside of cells are these things called DNA. Yes? Do you know what DNA is? Yes? So DNA holds the genetic information. It's almost as though they're blueprints to tell the cells how to look and act. So what I did is I used very new scientific methods in order to go into each cell of cancer, edit the genes. So I took out some genes and I made some genes happen a lot more times in the DNA. I amplified them. That's what that is. So I cut out some genes and I amplified some genes. So with my changed DNA, I was able to make those cancer cells act differently. And by act differently, I mean I changed the way that they were modal and the way that, how quickly they divided. So when cells grow, particularly cancer, the thing that makes them incredibly deadly is that they divide extraordinarily rapidly and they have a tendency to want to migrate into other tissues. Cells that are cancerous don't really want to stay put. They might be there, and then they'll want to slip out, go into your bloodstream, discover other parts of your body. And that cancer cell is very ambitious. But after editing the genetic information inside those cells, its desire to leave, its desire to move, decreased, and those cells didn't move as much. So that was pretty much my most recent study when it comes to cancer. Does anyone else have any other questions? Does that make sense? Yes, ma'am. Back there, blue shirt, long sleeves.
Are you planning to go to college?
Yes. So I'm a senior in high school. So usually right after high school, you head off to college. And yes, the answer is yes. I am definitely planning on going to college. And I highly recommend that everyone here do so as well. Because college is a phenomenal experience and opportunity in order to study a very specific field or to explore other fields and to just further your education. And education is wonderful. So thank you, and yes, I'm gonna go to college. I don't know where yet though. Yes, blue headband.
What's your job you're doing right now?
Pardon?
What's your job you're doing right now?
I'm a full-time student, so I'm in high school. So kind of just like you, in the mornings, I wake up, I eat my breakfast, and I go to school. And while I'm in school, I study the usual, English, science, history, the like. So that's pretty much my job. I'm a student, but on the side, I'm a speaker, I'm a singer, and I also do my cancer research. So if you consider those jobs, that's what I do. Does that make sense? Did that answer your question? Yeah. Awesome. Yes, ma'am. Is this my first science fair? It is not. So I've been doing science fair, this is my 3rd year now, and it's been an absolute breeze, but you can start doing science fair as early as 6th grade, so keep that in mind for next year. So throughout today, be listening to everyone's presentations and see if you have any questions that you might want to investigate, because if you do, that could turn into a marvelous science fair project. Yes, ma'am, in the red shirt. Oh, that's the big question. She asked, what would I like to be when I get out of college? And I don't have one, but 3 answers for you. Some combination of the 3. So first, I would like to be an oncologist. So an oncologist is a medical doctor who you see if you're suffering from cancer. So I would look into pursuing something called a medical degree and becoming an oncologist, specializing in immunology. Another thing would be I would always want to do cancer research. One thing that's cool about cancer research is that there are new developments all the time. What couldn't be cured 3 months ago is now curable today. It's absolutely astounding. It's a lot of fun to be in that field. So I would always want to be a part of research because research is very fast-paced and always developing. And if you stay at the forefront of research, you'll be able to better help your patients. So in regards to research, you'll need a degree called a PhD, which is a doctorate. I would want to be a professor. I'm pretty quirky, first of all. And second of all, I love teaching. I love sharing whatever I'm discovering or trying to discover. And I feel like when you're talking to a classroom of kids, it's almost as though there's a lot of untapped potential there. So, three-pronged answer: doctor, researcher, professor. Did that answer your question? Awesome, thank you. Anybody else? Yes, ma'am, cat ears, love that, meow. Yes, I did. So actually, my very first teacher, who I remember, she taught me how to read, and she taught me how to look at the world and to ask questions about everything around me. She is my mom, and she is here. She's right there. So that first teacher who made me want to discover things would definitely be my mom and my parents in general. And so it's really important that you listen to your, well, first of all, yeah, listen to your parents. And also be very aware of the world around you because there are issues and problems everywhere that you may want to solve. And I will take one more question. Does anybody have anything? Pink jacket right here. How long have I been studying about cancer? Thank you. So I started studying cancer when I was 13 years old. So I'm 17, 4 years. Yes. Well, I would like to thank you all for your time. And if you look up on the screen, I have my email here in case any of you want to talk about cancer or any aspect of STEAM. Also, hands if you have Instagram. Yeah. A little plug, that's my Instagram, it's the Onco Optimist. So if you want to continue following my journey of STEM, you can do so right here. So thank you all so much for your time, and I hope you have a wonderful day. There's great programming here today.
Thank you, Anabella, and we wish you well in all your endeavors, and you've certainly given all of us, hasn't she, a challenge. Thank you. At this time,